Hello everyone, welcome back to another session of Pythoning. Today is all about sorting. Yeah, I know definitely. You know everything about sorting. You know everything about ascending and descending order. You have sorted names, scores obtained by student, the price list, and many more. Right. So what's new about today? So generally, every time when you performed sorting, you might have used built-in functions like sort and sorted, isn't it? Cool. What if I ask you to sort data without using these functions? Is that possible? So that was the twist in the story. Cool. And now you know the theme behind today's roller coaster is to explore and dig into various methods and techniques that would enable you to sort the data without these functions. Or technically, I must say, you're about to learn various sorting algorithms. So when I say about sorting algorithms, there are many kinds of sorting algorithms like bubble sort, insertion sort, quick sort, merge sort, and the list goes like that. Okay, fine. Doesn't matter. But as for the CBSE curriculum, we'll be learning only two techniques, bubble sort and insertion sort. Cool. So let's start with the bubble sort. Now, to learn bubbles or think that you have reached the assembly ground and your teacher requests you to stand according to your height. What will be done here? Of course, you are going to see your adjacent partner, compare heights, and if you are not in order, you guys would shuffle positions, right? And this entire process gets repeated, and finally, you form a sequence arranged according to your height. Exactly. This is what bubble sort is all about. Cool. So let's do it technically with a list of numbers. Okay, so it's one of the simplest sorting algorithms. We are going to compare adjacent elements and swap them if I find that they are out of order. So if this is a list of elements, I compare adjacent elements and suppose I want to sort them in ascending order, I can find this 15 is bigger. In ascending order, the smallest element should be coming forward. So this is bigger. So what I do is I will be shuffling these two elements so that they get its position. And this process exactly is repeated to rest of the elements as well. So as you move ahead, you will find that after every pass, after every iteration, the largest element bubbles up towards its correct position. That's the reason this sorting algorithm has the name bubble sort. So I hope definitely you would like to see each and every set. So what are we waiting for? Let's jump on. Okay, so let's see. Few elements are there in a list and I have started with 15 and 9. 15 is bigger and so what I do is these two guys are shuffled. Now what has to be done? Yes, 15 has to be compared with 8. So let's compare 15 and 8. 15 is again bigger. So what should be done? Yes, shuffle them. Okay, so shuffling has been done. And what we are going to do next is, yes, move ahead. 15 and 30 will be compared. And you can see 15 is not bigger. So no change in the array. The array is same. 9, 8, 15, 36 and 4. But we will be moving ahead and comparing 30 and 6. And when you compare 30 and 6, 30 is bigger, so again shuffle. Go ahead, 30 and 4. 30 is bigger, shuffle them. Cool. What we have seen over here, one phase is over. I have reached the end of the array and you can see the largest element. The 30 is the largest element and it has reached its correct position. But unfortunately you can see my array is not sorted. So what is supposed to be done now? Leaving this 30, again I will be repeating the same procedure with rest of the elements. Cool. So that's iteration 2. Let's begin again. Okay. 9 and 8 are compared. 9 is bigger. So yes, swap them. Now go ahead, compare 9 and 15. Now it's smaller, no change. 15 and 4 are compared. Swap them. Okay, now 15 and 6 will be compared. 15 is bigger. Shuffle. Okay, so here you can see that I have reached the end of the list. 30 does not require any comparison because it's already reached its correct position. So what's the point of comparing 15 and 30? But as you can see, notice here that by the end of the second stage, the second largest element reached its correct position. So what is left out? Yes, I am supposed to arrange only the n minus 2 elements. Isn't it a magic? Okay, so let's proceed. 8 and 9 are compared, no change because 8 is smaller. Now 9 and 6 are going to be compared. 9 is bigger, swap them. Cool, 9 and 4 are compared. 9 is bigger, swap. Now, see, I don't have to compare 15 with 9 because I know 15 already had reached its correct position. So in every phase I can just lower down my number of comparisons. That's some technical point which has to be noted. But still my array is not sorted, but the third largest element has reached its correct position. Okay, cool. Now let's repeat. Phase 4. 8 and 6, shuffle. Now 8 and 4, yes, 8 is bigger, so again swap them. Cool. So now 8 has reached its correct position. Now what is left out is to sort 6 and 4. Okay, so I have reached phase 5. So iteration 5 is going on. 6 and 4 are compared. And finally you can see, wow, the array is sorted. Okay, finally you got all the elements sorted in ascending order. So now as a part of conceptual building, let's do one assignment because hands-on experience is very important. Another question is from compartment exam 2017 where you're going to list out the first, second and third pass by using the bubble sort algorithm and arrange the following element in descending order. Of course, clearly underline the stages, this comparison and how the elements get shuffled. Cool. Try it out and the solution is provided through the link in the description box. So that brings us to the end of this session. Follow the next video to dive into the coding part of this algorithm. Let's put our thinking caps on, get set and happy coding!